solve the system of following equations, of course using matrix method. So you have done so many such questions. What do you do? The only problem in this case is that instead of directly say 2x plus 3y plus 10 z equal to 4, x, y, z are in the denominator. So we can consider that 1 by x, 1 by y, 1 by z, as if first we have to solve for 1 by x, 1 by y, 1 by z. So you rewrite it in matrix form. Rewrite the question in matrix equation. Like you write the coefficients 2, 3, 10, the coefficient matrix, 4, minus 6, 5, and 6, 9, minus 20. That is your coefficient matrix. And the variables, as I said, instead of x, y, z, for a moment you consider like 1 by x, 1 by y, and 1 by z, and equal to the constant matrix 4, 1, 2. Okay, so now it can be rewritten as the variables we consider like 1 by x, 1 by y, 1 by z, the variable matrix equal to A inverse. A I am calling to this coefficient matrix. A inverse into 4, 1, 2, this matrix. So keep it here and find the inverse of the coefficient matrix to what I am calling A and then substitute. So let us start finding A inverse. So what is your matrix A? The coefficient matrix. The coefficient matrix is 2, 3, 10, 4, minus 6, 5, and 6, 9, minus 20. You know the definition that A inverse is 1 by determinant A into adjoint A. So in any case we need to find determinant A first. So let us find the value of determinant A, and we are expand it along row 1. So you get 2 times, delete the row and column through 2, you get here it is minus 20, please make a correction, minus 20. So you get 120 minus 45 and minus 3 times, delete the row and column through 3, you have minus 80, minus 80, minus 30, minus 80, minus 30, and plus 10 times, delete the row and column through 10, you have 36 and minus plus 36. So you get 2 into 75, this is 120, please make correction, 2 into 120 minus 45. So you have 2 into 75 and minus you take common, so it will be 3 into 110 and plus 10 into 72. So you just work it out and you will get the value of determinant A equal to 150 plus 330 plus 720, and finally it will be 1200. So yes, we have got the value of determinant A. You keep it with you, and finally we will require to find A inverse. So determinant A is 120. Determinant A is 1200. And now let us find the value of adjoint A. You know the value of adjoint A, it is the transpose of the cofactor matrix. That is, transpose of a matrix obtained by each element by the corresponding cofactor C11, C12, C13, C21, C22, C23, C31, C32, C33. And you know how do you work out the cofactor? Delete the row and column through that particular element and work out the rest of the second order determinant with proper sign, and the signs are plus, minus, plus, minus, plus, minus, plus, minus, plus. You know the sign convention. So now working out all these and substituting, you get adjoint A equal to transpose of C11 will be plus times 120 minus 45, and C12 will be minus times minus 80 minus 30, and C13 will be plus 36 and plus 36. Likewise, you work out the other elements, you will have minus times minus 60 minus 90, and then plus times minus 40, minus 60, and minus times, you will have 18 minus 18. The elements of the third row will be, the cofactor in the third row will be plus 15 plus 60 minus 10 minus 40 and plus minus 12 and minus 12. So you work out, you get adjoint A as transpose of 75, 110, 72, 150, minus 100, 0, and you get third row, elements of the third row as 72, 0, and minus 24. And now you take the transpose of it. Take the transpose of it. So finally you get adjoint A as, write the elements of the first row, that is 75, 110, and 72 in the first column. Elements of the second row, that is 150, minus 100, and 30 in the second column. And the elements of the third row, that is 75, 30, and minus 24 in the third column. So that way you have now got adjoint A. Already you know the value of determinant A is 1200. So what will be the value of A inverse? A inverse is 1 by determinant A into adjoint A. Replacing, you get A inverse equal to 1 upon 1200, and here you replace the elements of adjoint A, which already in the previous step we have worked out. So finally, and now from 1, what is the value of this variable matrix, say 1 by x, 1 by y, 1 by z? It is A inverse. So we have worked out A inverse as 1 by 1200 into adjoint A. You worked out at 75, 150, 75, and then elements of the second row are 110, minus 100, 30, and that of the third row are 72, 0, minus 24. And what is the constant matrix? It is 4, 1, 2. And now it is a matter of multiplying the two. So you have 1 upon 1200 outside. Multiply the elements of row with column. You get 75 into 4, that is 300, plus 150 into 1, that is 150, and plus 75 into 2, you get 150. Then repeat the process with the second row. You get 440 and minus 100 and plus 30 into 2, 60. Then similarly multiply the elements of third row with this 412. You get 288 minus 0 plus 48, or you get minus 48. Yes, you get minus 48. Minus 48. So you work out, you get 1 by 1200 yet outside, and you add the elements, you get 600, and you get 400 and 240. Divide each element by 1200, so you get 1 upon x, 1 upon y, 1 upon z equal to, dividing by 1200, you get 1 by 2, 1 by 3, 1 by 5, because 240 divided by 1200 will make it 1 by 5. Equating the respective elements, you get 1 by x is equal to 1 by 2, 1 by y equal to 1 by 3, 1 by z equal to 1 by 5. So now by cross multiplication, what do you get finally? X is equal to 2, y equal to 3, and z equal to 5, and that is the required solution.